Now, this process of referrals, as you can see, can be rather slow. A particular DNS query might thus require round trips to multiple servers that are authoritative for different parts of the hierarchy. The blue server is authoritative for the root, the purple server is authoritative for .edu, and the red server is authoritative for Gatech.edu. Now, supposing we wanted to save the extra time and trouble of these round-trip times, this local resolver would typically have a cache that stores the NS records for each level of the hierarchy, as well as the A records. And each of these answers would be stored or cached for a particular amount of time. Each one of these replies has what's called a time to live, or a TTL, that indicates how long each of these answers can be saved before they need to be looked up again. Caching allows for quick responses from the local DNS resolver, especially for repeated mappings. For example, since everyone is probably looking up domain names such as google.com, it's much faster to keep the answer in cache. So given multiple clients trying to resolve the same domain name, the answers can all be resolved in a local cache. Some queries can reuse parts of this lookup. For example, it's unlikely that the authoritative name server for the root is going to change very often, so that answer might be kept or cached for a much longer period of time. A typical time might be hours or days, or even weeks. The mapping for a local name, such as www.gatech.edu, on the other hand, might change more frequently, and thus these local TTLs might need to be smaller. Now, the most common type of DNS record is what's called an A record, which maps an IP address to a domain name. But there are other important record types as well.